Let's get curious. Hey everyone, and a massive welcome back to Tech Curiosity Stream. It's fantastic to have you all here with me today. This is the place where we dive headfirst into the fascinating world of technology, untangling complex ideas and making them simple. We're all about feeding that natural curiosity that drives us to ask how and why about the digital tools and systems that shape our modern world. So, if you love exploring the nuts and bolts of how things work, you have definitely found your tribe. We are here to learn together, question everything, and have a bit of fun along the way. Before we jump into the deep end of today's exciting topic, I just want to give a quick shout out to all our new viewers. If this is your first time tuning in, make sure you hit that subscribe button right now. Seriously, go ahead and click it, and don't forget to ring that little notification bell next to it. By doing so, you'll become part of our growing community of tech explorers. You won't miss a single episode where we break down everything from cloud computing to the latest in artificial intelligence. It's honestly the best way to stay in the loop and keep your curiosity sharp. Have you ever used an app or a website and suddenly it just stops working? Maybe a button doesn't respond or a page takes forever to load and you're left staring at a spinning wheel of doom. You probably wondered, what on earth is going on? Well, you're not alone. The engineers who built that software are asking the exact same question, but with a lot more urgency. In today's world, software systems are incredibly complex. They're not just one single program running on one computer. They are a sprawling network of interconnected services, databases, and components, all working together. This complexity creates a huge challenge. When something goes wrong, finding the root cause can feel like searching for a needle in a massive, ever-changing haystack. It's a mystery that can cost companies time, money, and honestly, a lot of frustrated users. Traditional monitoring might tell you that something is broken, like a warning light on a car's dashboard. It might flash engine problem, but it won't tell you if it's a spark plug, a sensor, or something else entirely. This is where the old ways of looking at system health start to fall short. They can spot the smoke, but they can't always lead you to the fire. This is precisely the problem that observability sets out to solve. It's a fundamental shift in how we think about understanding our systems. Instead of just waiting for predefined errors to pop up, observability gives us the power to ask any question about our software and get an answer. Why is this specific user in Brazil having a slow experience? How did that one bad transaction affect the entire checkout process? It's about moving beyond the known unknowns, the problems you expect, and being able to investigate the unknown unknowns, the bizarre and unpredictable issues that inevitably arise in complex systems. So get ready, because today we are putting on our detective hats. We are going to unlock the secrets of observability. We will explore how it provides the clues, the logs, metrics, and traces that engineers need to solve these deep technical mysteries. Well, it's not magic, but it is a powerful combination of three specific types of data. These are often called the three pillars of observability: logs, metrics, and traces. Think of them as three different types of clues that, when used together, allow our tech detectives to solve even the most baffling digital mysteries. Each one gives you a unique perspective on your system's behavior. Imagine you are investigating a crime scene. Logs would be like the detailed, moment-by-moment witness testimonies, telling you exactly what each person saw and did. At its core, a log is a simple, time-stamped message about a specific event that happened at a specific point in time. It's like a diary entry written by your application. Every time something interesting occurs, a user logs in, a file is saved, a database connection fails, the application can write a line in its diary saying, "At this time, this thing happened." If logs are the detailed diary of your system, metrics are the high-level scoreboard. A metric is a number, measured over a period of time. That's it. It's a numerical representation of the health or performance of a system. Think about things like CPU utilization, the amount of memory being used, the number of user signups per hour, or the average response time of your website. If logs are the detailed diary and metrics are the scoreboard, then traces are the play-by-play commentary for a single transaction. A trace follows one single user request on its entire journey through your complex distributed system. Imagine a user clicks Buy Now on an e-commerce site. A trace captures this entire path. It's made up of individual steps called spans. Each span represents one piece of work done by one service, and it records how long that step took. Let's start with a classic scenario that many of us have experienced, a frustratingly slow online checkout process. Imagine a large e-commerce company getting ready for its biggest sale of the year. They've prepared for months, but on the day of the sale, their monitoring dashboards light up like a Christmas tree. The metric for average checkout time has skyrocketed. Customers are complaining on social media that it's taking forever to complete a purchase, and many are abandoning their carts. This is where the old way of doing things would involve a frantic scramble. Engineers would start guessing. Is it the database? Is it the web server? Is the payment gateway overloaded? Now, let's replay this scenario with a team that has a mature observability practice. When the metric alert fires, they don't panic. Instead, they turn to their observability tool and look at a trace for one of the slow checkout requests. Instantly, the team sees it. The span representing the call to the inventory check service is taking over 10 seconds to complete, while every other service responds in milliseconds. Our next story comes from the world of digital entertainment. A popular video streaming service started receiving scattered reports from a small number of users who were getting a mysterious playback failed error 500 message. Using their observability platform, they started asking specific questions. They filtered all the error events by user location and immediately noticed a pattern. All the users reporting the error were concentrated in a specific geographic region. The traces showed that for these specific users, the request was being routed to a particular content delivery network partner that was misconfigured for a new video encoding format. To practice observability, you need the right set of tools. Think of it like a detective's kit. You need magnifying glasses, fingerprint dusters, and evidence bags to solve a case. First, you have the all-in-one commercial platforms. These are powerful, polished products from companies like Honeycomb, Datadog, New Relic, and Dynatrace. On the other side of the spectrum, you have the open-source world. Tools like Prometheus are the king of metrics, while Jaeger and Zipkin are fantastic for distributed tracing. Now, once you've chosen your tools, you might think the job is done. You just install the software and poof, you have instant observability. Unfortunately, it's not quite that simple. Observability isn't just a product you buy, it's a capability you build. The tools are essential, but they are only effective if you feed them the right data. This process is called instrumentation. Think of it like installing security cameras in a building. Just buying the cameras isn't enough. You have to strategically place them in the right locations to cover all the important hallways and doorways. One of the most exciting new frontiers is the concept of continuous profiling. Think of it as an MRI for your code. While traces show you the path of a request and where time is spent waiting, profiling goes a level deeper. As we collect more and more of this rich observability data, a new challenge emerges. How can humans possibly keep up with it all? This is where artificial intelligence for IT operations, or AIOps, comes into play. Imagine a future where you don't have to wait for an alert to tell you something is broken. An AIOps platform could proactively notify you, predicting issues before they impact users. We've covered a lot of ground today, but I want to end by focusing on the single most important component in this entire ecosystem, and it's not a piece of software, it's you. More specifically, it's your curious mind. In this new world of complex systems and abundant data, the most valuable skill you can cultivate is a deep and unrelenting sense of curiosity. It is the engine that drives all discovery and the true superpower that will set you apart in your tech journey. The best tools in the world are useless if no one is asking interesting questions. Observability platforms don't find answers on their own. They respond to the inquiries of a curious human. If you enjoyed this deep dive and want to continue exploring the most interesting topics in technology with us, please make sure you're part of our community. If you haven't already, take a moment right now to click that subscribe button. And don't forget to also hit that little notification bell icon next to it. That way, you'll be the first to know whenever we release a new video. Your support truly means the world to us. Our goal here at Tech Curiosity Stream is to keep feeding your hunger for knowledge. There are so many more mysteries to solve and so many more black boxes to open up. Thank you so much for spending your valuable time with me today and for sharing in my curiosity. Keep asking questions, keep exploring, and never lose that desire to understand how things work. See you in the next video. Until then, stay curious,